Today we start Module 4, Divide and Conquer Part 1. So this topic is relatively big, so I like to split it into two parts. Part 1 and Part 2. But for Part 1, I need to use some time to do some exercise questions. So for Part A, I want to use this whole session to explain selected questions in Homework 1 assignment. I select 6 relatively hard questions. All right, so the Part 8.1 explanation for question number 1 in Homework assignment 1. All right, so let's look at this question. Is it possible that the greatest common divisor function, GCD of m and n, is not defined for two integers m and n? Is it possible? Is there a special case not defined? So we can also call it undefined case. Here we consider special case, GCD of 0 and 0. So this special case, so many of you can guess it. This special case. So now let's consider GCD of 0 and 0 equals what possible values we can consider here. So I explain one by one. The first one is 0. Second one is undefined. The third one, infinity, right? Anyone think about infinity here? So here, let me explain it. So the reason I want to explain these cases, because one student sent me an email, asked me about 2 values he found from web search. From the web search, sometimes you could get different answers, right? So here there is a possibility. So the answers you found could be wrong. Could be wrong. So here, let me explain. So you need to use your knowledge. So what you have learned in our class, you need to find out which one is correct, which one is incorrect. Here, let us look at that question. First, let's consider the first case. Is 0 correct or not? All right? Here we use the thinking counterexample, not counterexample. So here we use the thinking contrapositive, right? Contrapositive method. How about that? So I used, counterexample, not counterexample, contrapositive method. So you know that, right? Here. Contrapositive method. In discrete math, you learn this method, right? In math proofs, we always, not always, we frequently use this method, contrapositive method. Here, we use this method to show if this is correct, we get some contradiction. How about that? All right? So when we start, we notice that GCD means greatest common divisor. The meaning is clear, right? So you have greatest Then you have common divisor, two pieces. Yeah. We need to address both two pieces. All right. Think about this first. 0 and 0. The first 0, can we write it as 1 times 0? It's correct, right? No problem. Yeah. The second 0, we can also write 1 times 0. How about that? Okay. All right. Now you look at the 1 upper equality, 1 lower equality. Can we say that 1 is a common divisor of 0 and 0? We can say that, right? Common divisor, yeah, common, divisor, yeah. 1 multiply 0, divisor, yeah. All right, so 1 is a common divisor, right? But now someone told me 0 is the greatest common divisor, right? Greatest. If you claim it's greatest, then based on the greatest meaning, right? Based on the greatest meaning, we should have 0 greater than 1, right? Because this 1 is not the greatest. Yeah. We do not say it is greatest. We just say it is a common divisor, right? Or, yeah, because, yeah, here we can do this. 0, its greatest should be greater or equal to any common divisor, right? Yeah. Greatest common divisor should be greater or equal to any common divisor. That must be correct based on the definition, right? Is this a contradiction? This causes contradiction, right? Yeah. Then, by that contrapositive method, the claim of GCD of 0 is equal 0, it is incorrect. We disprove it, right? We prove it's wrong, so we disprove it. All right, so that's the first case. Another case I want to explain, this infinity case. Because some people may feel that it could be infinity, right? Yeah. Why those people think it could be infinity? Because 1 is a common divisor, right? 2 is a common divisor. 3 is a common divisor, and so on. 1,000 is a common divisor. 1 million also common divisor. 1 billion common divisor, right? You can never find the largest common divisor. You can never find largest. Yeah. So then infinity, how about that? Infinity, yeah. Here I want to say you call infinity not good. Why? Because first we know infinity is not a number. It is not a number. We cannot call it a number. So what's that? It is the trend, right? It is a trend. It represents some special meaning related to trending. That's infinity. Okay? For example, when we consider limit, we use infinity, right? Limit. Yeah. All right. So usually when we consider limit, yeah, here let me use a special example. That's infinity, right? Yeah. The meaning of this limit equals infinity, we have rigorous definition for it. Rigorous definition. Here I do not want to repeat. Yeah. From calculus you can find that limit. We know there is specific rigorous definition out there. Yeah. Anyone can find it easily. Yeah. I do not need to mention it. Yeah. But it's not a number. It is a trend. The detailed meaning, yeah, that paragraph of definition. So not a number. Yeah. But here it's not that case. Here, if you claim infinity, is the meaning of infinity match the definition of that limit infinity? Maybe not, right? But you cannot connect in that way. Yeah. So then we can say infinity is not a good answer. Not a good answer. Right? Yeah. So then you need to look at undefined case. Nobody can define what is the value it is. Nobody can find a right way to say the value of GCD of 0, 0, right? Can anyone find appropriate value? Right? Yeah. All right, so that's what I want to explain for this first question. Yeah. All right, so let us stop right here. Yeah.